Okay, hi and welcome to your video notes for tonight. Tonight we're going to be talking about two-way tables. I'm Mr. Hallam. Let's get down into it. I've made some definitions for you, minus one that I added in late, so go ahead and add a bullet point right there. Don't tell anybody. All right, so we're going to take a look at some definitions. They look wordy, kind of crazy, but we're going to break them down and make them nice and neat. This over here will be what you want to get down. This will be your notes. This is how I would interpret the information we're done. So let's get to that and see if we can compare the two. So first thing we're going to do is talk about what a two-way table is. A two-way table is two variables that we're going to be looking at, particularly x and y. So we just use x and y. You're like, Mr. Hallam, that's linear. No, it's really any variables that we want to talk about. Could this be linear? Absolutely. This could be any type of function, really, if we were to graph it and look at it that way. But for our intents and purposes, we're going to look at these data collected. And we're going to take totals on them, and we're going to compare them in ratio, percent, if you will, together. So let's go ahead and take a look at some of these definitions. First things first, a marginal total then is what we're going to do is quite literally what it says. It says margin, and we know the margins are on the edges. So here's an example of a two-way table that we're going to use in a minute. And in here, if we were to calculate the marginal totals, I've already done that for you. You can copy those down. It'd be adding up each column down, and you can see the total at the bottom. Those are your marginal totals. Okay. Now, you also get another set of marginal totals, which would be the row marginal totals. So you would add these up across. And what that allows us to do is get different information. We can see how many students are in athletics, 600. How many students participated across all the grades in fine arts, 435. So we already get a piece of information just looking at the marginal totals for both. Here's the 9th grade students population. Here's the 10th grade student population. Again, ones that are participating in this particular set. And we don't know if there's more. There could be less. I'm assuming not every student participates totally. So that's a marginal total. Check on marginal totals. Now, we're going to take a look at marginal relative frequency. And it's kind of what it says there. We're going to look at the frequency based off of the margin totals there. So what we're going to do is we're going to take the margin totals and we're going to compare them to the total table. What does that mean, Mr. Allen? Well, if we wanted to see how many 9th grade students were participating over the whole school, we'd look at this marginal total here, this 375, and compare it to the table total, that's what TT stands for, of 1600. And it's going to tell us the percent of 9th graders participating in these events. Okay? So let's take a look at I missed one here, the joint relative frequency. That's the one that really should be in there, but that's okay. It really is asking us to look at these joint conditions, athletics and 9th grade, and compare them to the whole table total. So instead of looking at all of the 9th graders compared to the table total, or to the ones participating, we're going to look at, let's say, 9th grade athletics. How many 9th grade athletics students are there participating? So we'd compare that to the whole total. And that would show us how they would be, what percent they would be out of all of the school. So that would be a joint relative frequency, as in joint, two conditions to kind of essentially work with there. All right, the last one we're going to talk about is conditional relative frequency. And conditional relative frequency means that we're going to look at one condition here and we're going to compare it to that marginal total. So right here, cell count, and cell count means just what's in a cell, and compare that to the marginal total. So where in the last example I was talking about, we said we'd compare 150 to see how many 9th grade athletic students there are, compared to 1600, which compares a school. Now we're going to do is look at that 150, which is 9th grade athletics, but we're going to compare it to the marginal total, meaning of everyone participating in 9th grade. So we get a different percentage. So now we know the population participating in 9th grade. So you can see how these are actually fairly straightforward, and they give us different pieces of information. The tricky part about any of this is the way that they're worded. Sometimes they don't tell you marginal relative frequency. Or you notice nicely in this example or in these questions that I've asked you, they have, in other words, here's what you find. When you get in there and you start doing some of the homework and you start doing some statistics, you have to decide what one applies, which one they're asking for, and which calculation to do. That's actually the hard part of these notes. This part will be pretty easy because you'll just get to see it. So let's go ahead and jump down into these examples. We'll assume that you've already calculated the marginal totals or wrote mine down. And now we've go ahead and you see where the 1600 comes from, right? Adding up all the marginal totals. That's where that 1600 comes from. So check on those, both check. So let's calculate some of these. This one says calculate the marginal relative frequency. Marginal relative frequency, so MT over TT. So we're looking at marginal totals, edges, over the table total. for ninth graders. So we're going to look at the relative frequency of ninth graders. So we're going to find ninth grade. Here's ninth grade. And we're going to take this total here, this 375, and we're going to compare it or put it in reference to the table total. So 375 over 1600. Now, I'll spare you the time of reducing the fractions and showing the decimals, but you should ideally first, because it gives us a perfect answer, reduce the fraction. That's how we really should have it. But two, if you're going to use it or graph it or talk about it, a lot of times we'll change it to a decimal, which really means we'll change it to a percent and talk about it. So first, reduce the fraction. Second, if you need to, depending on the situation, go ahead and change it to a decimal. Do not leave it as this. All right, so now let's go to the next one. It says calculate the marginal relative frequency for athletics, right? In other words, what fraction of students participate in athletics after school? So here's athletics, here's all the grades, here's all the students participating after school. So we're going to go ahead and compare those two. So 600 compared to the 1600 in the whole school participating in this group here. So let's erase those so we keep moving. All right, the next one says calculate the joint relative frequency, and we'll go up here. That means we're going to be looking at a cell count compared to the whole table, so just so we have it in our mind. So it says to calculate the joint relative frequency for 10th graders and the number of students who participate in fine arts activities after school. So here's the fine arts, and I'm circling 9th grade, so let's circle 10th grade. Here's fine arts and 10th grade. So two conditions, fine arts, 10th grade. And we're going to compare that to the whole school. So we'll find out how many 10th graders in this whole situation are participating in fine arts. So we would take that 90 and we'll go ahead and divide that by 1600. Again, reduce, reduce, reduce. All right, the next question then asks us to calculate the joint relative frequency of 12th graders and the number of students that participate in other activities. So we're looking at 12th graders and others. So 12th grade others right here, 12th grade and others compared to the whole school. So we're going to take 150 and divide that by 1600. Now, normally we would do something with this information. At this point, we're just practicing finding it, and you get to do stuff with it tomorrow and the next day. All right, so now we're going to move on. We're going to go ahead and calculate the conditional relative frequency. So let's go see what that is again. Conditional relative frequency says we're going to look at a certain cell, and we're going to compare that to the margins this time. So we're going to do this for the number of students participating in athletics and 12th grade. So let's identify them, athletics and 12th grade. Let me get rid of these marks. Here's athletics, here's 12th grade. There's 150. And we're going to compare that to the marginal total, right? So let's see which one we're going to be looking at. So it says who are 12th grade. In other words, the 12th grade group, that what fraction of students participate in athletics after school. So we want to compare that to not the total number of students in athletics, not 12th grade versus athletics, but just make sure we find that again, the school who are 12th graders participating in athletics. So here's 12th grade compared to athletics. So we're going to take 150 and divide that by 425. Okay, so now we're checking 12th graders in athletics, not 12th graders in athletics. Do you see the wording complication there? You got to be a little careful with that. All right. Again, calculate the conditional relative frequency for the number of 11th graders who participate in fine arts activities. So let's find 11th graders. Here's fine arts activities, so I'll erase this one here because we don't need that anymore. 11th grade fine arts activities, right there. So we want to see the number of 11th graders who participate in the fine arts activities. So here's 11th graders, 410 total participating, and 120 of them are participating in fine arts. So 120 divided by, I already forgot the number, 410, and that will give us that percentage there. All right, so the next question then says, for each grade level, find the ratio of students who participate in athletics after school. Notice it doesn't tell us which way to calculate this. So for each grade level, we want to find out how many students are participating in athletics. So we're going to be looking at each one of these, and we want to know how many are participating in athletics. So we're going to take a look at 9th grade athletics, right? So here's 9th grades, and again, let's make sure that we get this correct. So each grade level, find the ratio of students who participate in athletics after school. So the ratio of students versus athletics after school for each grade level. So we're going to be looking at these totals here because we want to look at the totals per the grade. So we're going to compare that number, 150, to 375 for 9th grade. So 9th grade is 150 compared to 375. That is the 9th graders participating versus all of the 9th graders in athletics, of course. Again, reduce. So let's find 10th grade now. So we'll do the same thing. So 10th grade is going to be 160 compared to 390 this time because there's more people participating in 10th grade than in 9th grade, which would make sense, wouldn't it though? 11th grade then. So 11th grade is going to be the comparison of 140 versus 410. And finally, 12th grade is going to be the comparison of 150 to 425. Again, we would need to calculate the percents here, which we did not do. So it says which grade level has the highest ratio compared. So this is actually where we'll need to do that. I'm going to pause and do those calculations for you quick. So hold on one sec. Okay, so I've done the calculation for us. We find out that 40% of the 9th graders are participating in athletics, 41% in 10th grade, and then it drops a bit in 11th grade to 34, and then seniors are in the vicinity at 35%-ish. So which level has the highest ratio? Obviously, that's going to be our, let me grab a pen here. Our highest ratio then is 10th grade as our highest, and which has the lowest, which would be our 11th graders, looks like. Okay, so the last one I already did for us and left out, so we could just kind of talk about it. It says for each activity, find the ratio of 9th graders that participate, and then which activity has the highest population of 9th graders and which has the lowest. So very similar to the last question, but this time we're looking at for each activity versus the grades. So now we're going to go up there in the activity. You can see in the first one, we're going to check athletics. So we're kind of doing the sideways version of what we just did. So this time we're going to compare athletics for 9th grade versus its marginal total this way. So you can see the difference. If we're looking at the grade levels, we're going to look this way for this table. This time we're looking at the actual events or activities. So we're going to look across. So the total people in athletics is 600 across all the grades, and for 9th graders specifically, it's 150. And the same thing for fine arts, it'd be 100 to 435, and then 125 to 565. So you can see those percentages there. I went ahead and marked. It looks like athletics is the highest at 0.25, and the lowest then would be other activities, which I'm not sure what those include. All right, so there's your notes. It's a 12-minute video. It covers everything there. You have the basics on how to do these. Mark this as the important part about the notes, that you know those combinations so you can find these if you can work with it. But remember, wording is tricky with these. So if there's a problem, that's probably where you're at. So then you say, hey, I must be calculating the wrong thing. I might want to go back and recheck that. All right, I'll see you in class for some examples, but good work tonight, and we'll see you later.